Hello students, today's topic is combination of resistances or resistor. We know that the current, it depends on potential difference and the resistance. Some of the electrical circuits of radio or television, in those electrical circuits we need the desired value of current. Means we need to flows the current in those electrical circuits. The specific current you need to be flows through it. So in order to flow the desired value of current, we need to combine the resistors in those electrical circuits. So here we have the two methods to combine the resistors. One is series combination and another one is parallel combination. So let's study. First one is series combination. First one, series combination of resistances. Series combination of resistances. The definition for the series combination of resistances is, if a number of resistances are joined end to ends in between the 2 points, so that the current flowing through each resistance is same. So it is the definition for the series combination of resistances. So according to the definition, so how we need to combine the resistances? Look at here. So I will take the resistance, this one as R1, and this one as R2 resistance. Similarly, this one as R3. Let I take the point A and point B. So in between the 2 points, if the number of resistances are joined end to end, got it? So this resistance is having two ends, got it? Now the second end of the first resistance is connected with the first end of the second resistor. So here similarly, here also the second end of the second resistor is connected with the first end of the third resistor. So here like this, in between any 2 points, if we have connected the number of resistances one end after another, so this type of combination of resistances we will call as series combination of resistances. So let I connect the electric cell along with the plug key. Let V is the potential difference, and let the current flowing through the circuit is I. Now, when the switch is on, the current will flows through the circuit. Okay. Now, when the current enters at the point A, it has to be passed through the resistor R1, and it has to pass through the resistor R2, similarly R3, similarly here also, and it will enters to the negative terminal. So this is the path for the flow of electric current. Here the current flowing through the each resistor is same. Whatever the amount of charges are going to flow through the all these three resistors is same. For example, if I have taken 2 ampere of current, 2 ampere of current. Now this 2 ampere of current is going to flows through the resistor R1, R2 and R3. It's not like that when the current will reaches to the resistor R2, the current is going to be increase or decrease. It's not like that whatever the current is there, now here 2 ampere is there, it will come here 1 ampere. No, whatever the amount of current flowing through the circuit is same. So here current is same in the circuit. So we made the rule, when the resistances are connected in series, current is same in the circuit, or you can write current flows through each resistance is same. Got it? Now the potential difference, that is the voltage in the circuit, we have taken V. Now let's suppose that I have taken it is 4 volt. Now the potential difference for the circuit, it will not be same. It will not be same. How? We know that potential difference, it is the work done. It is the work done to move the charges. Okay. Now, if I taken these 2 points across the resistance R1, now charges or the current has to be passed through the resistance R1. Got it? It means work has to be done. Work has to be done to move the charges from one point to another point. Similarly, for R2, if I consider these 2 points. Got it? Now, work has to be done to move the charges from one point to the another point through the resistor R2. Now, similarly for the R3 resistor, work has to be done to move the charges from one point to the another point. Now, whatever the work has been done to move the charges in between the points is different. It is not same. To move the charges, the work done is not same. It means the potential difference is not same across each resistor. Across each resistor, the potential difference is not same. So here, the potential difference across R1 resistor is, I will take V1. And for R2 resistor, I will take V2. For R3 resistor, I will take V3. Got the point? Now, the total voltage in the circuit, total voltage in the circuit is the sum of all voltage drops. Correct? That is, V is equal to V1 plus V2 plus V3. Now this is the total voltage in the circuit, that is V. Now this voltage V, it is the sum of all the voltages across each resistor. Now let us suppose that here the total voltage in the circuit is 10 volt. Now the potential difference across the resistance R1 is, let's suppose that I have taken, it is 4 volt. Got it? Now remaining two resistance, the work done, it's going to be distributed 3 volt and 3 volt. Now add 4 plus 3 plus 3, it will be 10 volt. So the total potential difference is divided in all the voltages across each resistor. So we have made the rule, that is V is equal to V1 plus V2 plus V3. Okay. Now here let apply the Ohm's law to the each resistor. Apply the Ohm's law to the each resistor. By Ohm's law, potential difference across each resistance is, potential difference across each resistance is, apply the Ohm's law to this one resistance R1, you will get V1 is equal to I into R1. Okay, I into R1. So let us write this one once again. By Ohm's law, the potential difference across each resistor is V1 is equal to I R1. Just I have applied the Ohm's law to the resistor R1. So I can write according to the Ohm's law, V1 is equal to R into I into R1. Why? Because current is same through the each resistor. So I will take I. What is the potential difference? We have taken across R1 as V1. What is the resistance? R1. Similarly, V2 is equal to I into R2 and V3 is equal to I into R3. Got the point? Now, here by replacing all these three resistors, we can connect a single resistance between these 2 points, and that resistance we will call as equivalent resistance. Once again, in between these 2 points we have 3 resistors. Fine. By replacing these 3 resistors, we can use a single resistor. That resistance is called as equivalent resistance. Equivalent resistance. So equivalent resistance, if a single resistance is replaced by the combination of resistances, so that current through the circuit is unchanged. Current through the circuit is unchanged. So that is called as equivalent resistance. So here for this circuit I will take the equivalent resistance as RE. Fine. So here RE is the equivalent resistance. By Ohm's law, we have, now apply the Ohm's law to the whole circuit. Got it? I can write V is equal to I into RE. Why? Because for the whole circuit we are having the potential difference V, so I have taken V. For the whole circuit, what is the current? Current is I. We have replaced all these 3 resistors with a single resistance, that is equivalent resistance. So I have taken here RE. Got it? Now, let I call this one as equation 1 and this one as equation number 2. From 1 and 2 we have, look at here, the LHS are equal, so obviously the RHS are equal. This implies that IRE is equal to V1 plus V2 plus V3. Got? Now IRE is equal to V1 is equal to, already we have V1 is equal to RI into R1, I into R1, V2 is equal to I into R2, V3 is equal to I into R3. Fine, because V1 is equal to I R1, V2 is equal to I R2, V3 is equal to I R3. Simplify this one. This is equal to I into RE is equal to, take I is the common factor, inside you will get R1 plus R2 plus R3. This I and this I both are get cancels together. So here R equivalent is equal to R1 plus R2 plus R3. So here the equivalent resistance, it is the sum of individual resistances. So whenever the resistances are connected in series, the resistance, equivalent resistance is increased. So equivalent resistance will be increased when they are connected in series. So we have made the rule that resistance increases. So when the resistance is increases, when we have connected the resistances in series. Got it? Because here the individual resistances are going to be added. So for that sake, resistance is going to be increases. Got it? Now let's suppose that there are n number of resistances are there. So at that time, what will be the expression? For that sake, we have R equivalent is equal to N into R. That is up to n number are there, means the equivalent resistance will be equal to the formula R equivalent is equal to N into R. Remember this one formula also. It will be helpful for the when we will solve the numerical problems. Okay. So this is all about the study regarding the combination of resistances in series combination. So what will be the conclusion for this one combination of resistances in series? So note. So what should we note? First thing, current through each resistor is same. What will be the current rule? That is, rule for the current is current through each resistor is same. Whatever the current is flowing through the each resistor will be same when they are connected in series. Now what about the voltage, that is the potential difference? Look at here. The total potential difference, it is equal to V1, V2, V3. It means I will write here voltage is divided. Correct? Voltage is going to be divided in the circuit. That is V is equal to V1 plus V2 plus V3. This is the rule for the voltage. Now what about the resistance? What about the resistance? Equivalent resistance, this is the equivalent resistance, is equal to the sum of the individual resistances. The sum of the individual resistances. The sum of the individual resistances. So this is the rule for the equivalent resistance. And remember a very important thing, that the equivalent resistance, it is always greater than the individual resistances. Whatever the value you will get for the equivalent resistance, it is always greater than the values of the individual resistances. Got it? equivalent resistance is always greater than the values of individual resistances. Fine. So these are the main important note you need to be remember when the resistances are connected in series. Thank you.